Now let's talk about how to use Excel solver to determine the optimal staff scheduling problem. So the technique we are going to learn in this session, you can use the same technique to deal with one of the case study. So let's look at this problem. So here I have Excel file. In this Excel file, I have two tables. This first table and the second table. Let's first look at second table. So here I'm talking about the weekly staff scheduling problem. So in the second table, if you look at column C, we see 7 days from Sunday all the way to Saturday. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So 7 days in a week. In column D, this one shows the staff requirement. So here we're talking about hospital. So column D shows the minimum number of nurses required on each day of the week. So for example, if you look at Sunday, on Sunday we need at least 3 nurses. Monday we need 6, Tuesday 5, and Saturday 5. So these numbers are the minimum requirement. So that basically means when you determine the scheduling problem, you want to make sure you will have at least this many people on each day of the week. You can have more, it's not a problem, but has to be at least this many. So this is the minimum requirement. So you can see the minimum requirement is different on different day of the week because the workload can be different. For example, for a particular hospital, Sunday, typically you don't expect to see a lot of patients. So we only need 3 people, minimum only 3. But Wednesday can be pretty busy. Monday can be pretty busy. We need at least 6 people on duty. So this is about second table. Second table shows the minimum requirement, staff requirement on each day of the week. This is usually it's given information. Now let's go back to the first table. The first table shows a different possible shift. So if you look at second table, I have different requirement on different day of the week. So how do we schedule people to work on different day of the week? Some people say it's pretty simple. Let's simply schedule 3 people to work on Sunday, 6 people work on Monday, 5 people on Tuesday, 6 people on Wednesday, and 5 people on Saturday. It looks like it's pretty simple. But please be careful. When we determine a staff scheduling problem, we're talking about full-time employment. So you cannot hire somebody to work for 1 day only or 2 days only. We're talking about full-time. So whoever we hire, this person is going to work 5 days a week. So this person can work from Monday to Friday, for example, so 5 days a week, and then take 2 consecutive days off. So you cannot simply hire somebody to work for 1 day only. Whoever we hire has to work 5 days a week and then take 2 days off. So based on this information, this is a very realistic constraint and it's a common practice. So based on this information, in table 1, we'll list 7 possible shifts. So because everybody has to work 5 days a week and then take 2 days off, so these are the all possible shifts. For example, the first possible shift is having somebody work from Sunday to Thursday. That's 5 days. And then take Friday, Saturday off. So these are the working days. Work from Sunday to Thursday, taking Friday, Saturday off. That's the first possible shift. The second possible shift is working from Monday to Friday and then take weekend off. So Saturday, Sunday off. The next one, work from Tuesday to Saturday and then take Sunday, Monday off. So these are all possible 7 possible shifts. So these are different. This is possible shift. These are a different day of the week. So based on this requirement, now we have to determine how many people we want to schedule for different possible shifts. So that is a problem. So how to determine? Because we are using Excel solver, we are going to let Excel determine the optimal number to schedule for different shifts. So before we start, let's put some arbitrary number. So as I said, it's arbitrary, so you can put any number you want. You can put, to make it simple, you can put all 0. So that means you don't have to type anything. So here, to make things clear, I want to put some arbitrary number. For example, I want to hire 1 people to work from Sunday to Thursday, 2 people to work from Monday to Friday, 3 people from Tuesday to Saturday, and 4 people, 5 people, 6 people, 7 people. So these are the number of people I want to hire for different shifts. So again, these numbers are 1, 2, 3, 4, 5, 6, 7 arbitrary numbers. Those are not the solutions. So I just start with any arbitrary number. Eventually, Excel is going to change these numbers. So it doesn't really matter what number you want to start with. So I start with 1, 2, 3, 4, 5, 6, 7. You can start with 7, 6, 5, 4, 3, 2, 1, for example. You can start with all 100. You can start with all 0. It's up to you. It doesn't really matter. It does not affect your final solution. So I put some initial number. Now, based on this initial number, what I want to do, I want to fill column E, actual number of nurses on each day of the week. So if you do this scheduling, if you take this scheduling, okay, if let's say this is the optimal solution, if this is the case, how many people are actually working on Sunday? So this is something you want to figure out. So take a look. So who's working on Sunday? Look at these people, okay? So these people. I have 7 different group peoples. Look at these people. Who's working on Sunday? Obviously, you can see those who work from Sunday to Thursday will be working on Sunday, right? So this one person, this person working from Sunday to Thursday, obviously this person is working on Sunday. What about this one? Somebody working from Monday to Friday. If somebody is working from Monday to Friday, that means this person is taking Saturday, Sunday off. So this means this person is not working on Sunday. Similarly, somebody working from Tuesday to Saturday will be taking Sunday and Monday off. That means this person is not working on Sunday. What about next person? The ones who is working from Wednesday to Sunday. Is this person working on Sunday? The answer is yes, because these are the working days from Wednesday to Sunday. The next person from Thursday to Monday will be working on Sunday as well. The next person from Friday to Tuesday will be working on Sunday as well. And the last person, Saturday to Wednesday, will be working on Sunday. So based on our discussion, we want to figure out what's the total number of nurses who will be working on Sunday. So total number will be 1. It's the one person working from Sunday to Thursday, plus the person who's working from Wednesday to Sunday, which is 4 people, plus the ones who's working from Thursday to Monday, 5 people, plus the ones working from Friday to Tuesday, 6 people, plus the ones who's working from Saturday to Wednesday, 7 people. So basically, it's a sum of 1 plus 4 plus 5 plus 6 plus 7. Okay. So here, what we want to do is we don't want to simply type a number. We want to create a formula. Okay, we want to create a formula to calculate what is the actual number of nurses working on Sunday. So what's the formula? So how many people will be working on Sunday? 1 people, which is B2. So this many people, plus 1 who's working from Wednesday to Sunday, plus the 1 who's working from Thursday to Monday, plus 1 working from Friday to Tuesday, plus 1 who's working from Saturday to Wednesday. So these are the number of people who will be working on Sunday. The reason I use the formula instead of using the actual number, I use the formula because these numbers, remember, these numbers eventually will be changed by Excel. So we don't want to simply type a number, okay? We want to make sure these creates a formula to link the number with these numbers. So we use a formula. So we fill the first number. So 23 people altogether. 23 people will be working on Sunday. Of course, that's good. We need 3 people at least. We have 23 people. So obviously we can meet the requirement. But we probably overstaffed, right? We had too many people. We don't need 23 people. We only need 3 people. The next question is, who's going to be working on Monday? Who's working on Monday? What's the total number of people who's working on Monday? So let's look at this. Again, we're going to use the formula. So Sunday to Thursday, does that cover Monday? Sunday to Thursday. The answer is yes. So it's B2. What about Monday to Friday? Does that cover Monday? The answer is that, obviously, yes. What about Tuesday to Saturday? Those who work from Tuesday to Saturday will be taking Sunday and Monday off, so they will not be working on Monday. What about Wednesday to Sunday? Those who work from Wednesday to Sunday will be taking Monday, Tuesday off, so they will not work on Monday. What about Thursday to Monday? Yes, Thursday to Monday. What about Friday to Tuesday? Yes. What about Saturday to Wednesday? Yes. So this is the total number of people who will be working on Monday. What about Tuesday? Who will be working on Tuesday? We can do a similar analysis calculation. So who will be working on Tuesday? The ones who is working from Sunday to Thursday, obviously will be working on Tuesday. So B2 plus the one working from Monday to Friday plus one who's working from Tuesday to Saturday. What about Wednesday to Sunday? The one who's working on Wednesday to Sunday will not be working on Tuesday because Tuesday is off days. What about this? Thursday to Monday? The answer is no. What about Friday to Tuesday? Yes. The ones who is working from Friday to Tuesday will be working on Tuesday, plus the one who's working from Saturday to Wednesday. So this is the total number of people who will be working on Tuesday. Similarly, we can do this for Wednesday, Thursday, Friday, and Saturday. So I'll go over this quickly. So for Wednesday, who's working on Wednesday? Sunday to Thursday, plus Monday to Friday, plus Tuesday to Saturday, plus Wednesday to Sunday, and plus Saturday to Wednesday. So these are the people who will be working on Wednesday. What about Thursday? So Thursday will be Sunday to Thursday, plus Monday to Friday, plus Tuesday to Saturday, plus Wednesday to Sunday, plus Thursday to Monday. What about Friday? So who's working on Friday? So Monday to Friday, plus Tuesday to Saturday, plus Wednesday to Sunday, plus Thursday to Monday, and plus Friday to Tuesday. So who's working on Saturday? So Tuesday to Saturday, plus Wednesday to Sunday, plus Thursday to Monday, plus Friday to Tuesday, and plus Saturday to Wednesday. So these are the total number of people who will be working on each day of the week. These are the minimum requirement. These are actual people we hired. Clearly, as you can see, we overstaffed. We hired too many people. We don't need that many. So, but don't worry about it, because as I said, eventually Excel is going to change it. Okay, so this is just starting point. It's the initial solution. It's not the optimal solution. It's the initial solution. Excel is going to change the solution in the end. So after we fill column E, we need to fill one more number. So what is the total number of people hired? This number, B9. So what is the total number of people we hired? So if you look at the current solution, we hired 1 people for the first shift, 2 people for the second, and 3 people for the third shift, and 7 people for the last shift. So we want to figure out what is the total number of people we hired. So question, why do we care about this number? So what's the total number of people hired? Because eventually, as a company, we do care about the labor cost. So what is total labor cost? The total labor cost depends on how many people we hire. If you hire more people, that means you pay more labor cost. If we hire less people, we pay less cost. So this is something we are concerned about. So what's the total number of people we hired? This is simple. We simply sum up all these numbers. Sum from B2 to B8. So that number shows the total number we hired. So 28 people. So total, we hired 28 people. Question is, can we do better? Okay, can we do better? Do we really need to hire 28 people? Okay, so from column E and column D, we can see right now, based on current solution, we meet the requirement, we can meet the requirement, but we pretty much overstaffed. So clearly we can do better than 28 people. So how much better? We're going to use Excel. Okay, so use Excel. So click Solver. So as we discussed before, for a solver problem, we need to specify 3 different things. The first thing, we need to specify what is the objective. So what are you trying to achieve? So for this staff scheduling problem, we try to determine the number of people to hire for different shifts in order to bring down a total labor cost. In other words, we want to make sure the total number of people assigned or total number of people hired is minimized. Smaller the better. We want to minimize the labor cost. So what is the objective? The objective is B9. So B9 is the objective. We want to try to, we target at this number. Do we want to maximize this number or minimize this number? Again, because we want to bring down the labor cost, we want to minimize the total number of people we hire. So minimize. The next one is by changing variable cells. By changing variable cells means, so what are the decision variables? So what are the decision variables? If you look at this problem, we are trying to determine how many people to hire, the number of people to hire for different shifts. So the decision variable here is from B2 to B8. So basically all the numbers highlighted in green. So we choose these numbers. So pick all these numbers. So these are the numbers we want to determine. Right now, we already determined 1, 2, 3, 4, 5, 6, 7, but these numbers are arbitrary. So eventually we want Excel to change these numbers. So now we have the objective, we have the decision variable, we have to specify the constraint. Now we have to specify the constraint. So what are the constraints we have here? The first constraint, obviously, because if you look at column D shows the minimum number of nurses required on each day of the week. So these are the minimum requirements. So we have to meet these minimum requirements. That means what? When we schedule people, we have to make sure each number in column E has to be at least the same as column D. It can be equal to or greater than the corresponding number in column D. So column E has to be greater than or equal to the numbers in column D. So this is one constraint. The actual number of people we hire has to be at least as the minimum requirement. The first constraint, cell reference, I choose all the numbers in column E. So E2 to E8. So these are numbers are the actual numbers we hire. Has to be greater than equal to. Okay, not exactly equal. Don't choose equal. Okay, it may not be exactly equal. It has to be greater than equal to. To what? The right hand side is the minimum requirement. So the right hand side is D2 to D8. The constraint says E2 to E8 has to be greater than equal to D2 to D8. So that's the first constraint. We actually have one more constraint. A second constraint is not obvious, but it's implicit. So basically it means when we determine the number of people to hire for different shifts, we have to make sure these numbers, 1, 2, 3, 4, all the way to 7, all these numbers have to be integers. We cannot hire 1.2 people. We cannot hire 0.5 people. So all these numbers have to be integer. So this is an integer constraint. So we cannot hire people, hire a fractional number of people. So we add a constraint. We choose all these green numbers. Okay, choose all the green numbers. And in the middle, look at all these. Look at this one, INT. INT means what? INT means integer. So this means if I choose INT, that means I want to make sure all these numbers eventually are integer numbers. So we pick B2 to B8, and then in the middle, I pick INT, that means integer. Click OK. So these are the only two constraints. Okay. Now we're pretty much ready to solve the problem. So how do we solve it? Before we click solve, we want to make sure, as I said, in all the problems here, we only use one solving method, which is simplex LP. So we pick simplex LP, make sure you pick simplex LP. So pick simplex LP, and then click solve. So you see, solver found a solution. All the constraints are met. We want to keep a solution, we click OK. So that is our solution. Okay, so that is our solution. The total number of people we need to hire is 8 people. We're going to hire 1 people to work from Sunday to Thursday, 1 people from Monday to Friday, 2 people working from Wednesday to Sunday, 1 from Thursday to Monday, 1 from Friday to Tuesday, 2 people working from Saturday to Wednesday. So these are the actual number of people we hired on each day of the week. This is the minimum requirement. You can see sometimes they are exactly the same, sometimes it can be slightly higher. Okay, there's no way to perfectly match it because of 5-day constraint. There's no way to perfectly match it. So column D, column E are not exactly the same. Okay, but column E has to be at least the same as column D. Okay, at least it can be greater, but it has to be at least equal to it. So that is a solution. That is a solution. So now we're done. We already determined the schedule. Next question, what I want to do is how do we present the solution? Okay. Of course, some people can read it. It means we hire 1 people to work from Sunday to Tuesday, Thursday, 1 people to work Monday to Friday. To make it even clear, I can do a table. This is a table. This table shows the final solution. So you can see altogether, based on solution, we hired 8 people. So what the working schedule looks like for these 8 people? You can see for the first person working from Sunday to Thursday. So I use check mark, okay, to mark the working days. So first person working from Sunday, Monday, Tuesday, Wednesday, Thursday. Second person working from Monday to Friday. And then we have 2 people, nurse 3 and 4 working from Wednesday to Sunday, and have 1 people, nurse 5 working from Thursday to Monday, and 1 people working from Friday to Tuesday, and then I have the last 2 people, nurse 7 and 8, working from Saturday to Wednesday. So this is a table structure. It basically shows the same solution, but it's much clearer. It's much easier to read.